On pages 57 through 58, we're going to be taking notes over 3-7 solving matrices. So for 3-7 solving matrices, it's all pretty much calculator use. And so please make sure you also have a calculator available. The suggested layout for 3-7 is as following. You cut and paste your handout that you received. We'll do 3 examples on the page 57 and then 2 examples on page 58. They may or may not be exactly the same layout, but that's the gist of it.
Bro, what? Bro, what? But you looked at me so seriously too. I'll do it. No, I did.
So on again, on pages like this, if you're not following along and you're not taking the notes and you're not trying on the calculator, then it will be difficult for you. Otherwise, it's a fairly easy section as long as you are following along and doing your part to learn the content. That one doesn't work. If your desk has an extra calculator on it. All right, so yesterday we talked about finding the inverse and how to find the inverse. And today we are actually going to be using the inverse. You're not writing this part down because the steps are written down for you. But ultimately what we're doing, we have a problem. These represent matrices, not just variables. So the capital letter means it's a matrix. So if I have matrix A times matrix X equals B, to solve for matrix X, I find the inverse. Just like any other time in math, you do inverse operations, right? Same thing with matrix. You find the inverse matrix and then you multiply the other side by that to find your missing matrix. So the steps that you glued in on your notebook are as following. Step 1, we check that the determinant doesn't equal 0. The reason why we do that is because if it does, then there's no solution and you're done. If it doesn't, then you proceed with the following steps. Step 2 is to find the inverse of the given square matrix. So that's our 2 by 2. That's what your do now is over, making sure you understood vocabulary. Step 3 was to multiply each side by the inverse. And what happens when you multiply the left side by the inverse is that it creates the identity and therefore it ends up canceling out. Step 4, the solution is the 2 by 1 that's created after you multiply both sides by the inverse, okay? So our first example that you can go ahead and write down is matrix 5, 3, 3, 2 times matrix X equals matrix 1, -3. Okay, the goal here is to find matrix X. And so we're going to go through the steps that were listed out for you. So step 1 is just so that you know if you need to proceed or not. So step 1 is to find the determinant of the 2 by 2. So I'm looking for the determinant of 5, 3, 3, 2. When you're looking for the determinant, that means you cross multiply and divide. So I'm going to cross multiply 5 times 2 minus 3 times 3. That gives me 10 minus 9. which equals 1. But that lets me know that there is a solution to this matrix, so then I continue on to the next steps. The remaining of the steps are pretty much done in the calculator. So that's why it was important for you to have a calculator. So step 2 is to find the inverse of the 2 by 2 of your square matrix. So I have 5, 3, 3, 2, and I'm looking for its inverse. So that's what I type in the calculator to find the inverse. So I'm going to input this into the calculator. So I have my calculator. I'm going to select 2 by 2. I'm going to input the values. So I put exactly what was written down is I'm looking for the inverse of my 2 by 2. I input the matrix, input the -1, hit enter, and my inverse is yes. So that's step 2 is to find the inverse. Step 3 is to multiply your inverse by your solution. So the solution is 1, -3. So I'm going to multiply my inverse by 1, -3. That's step 3. In the calculator to do so, all you're doing is you're arrowing up, highlighting the inverse, pressing enter, and it brings it down. Then I'm going to click the button next to 9 and select a 2 by 1 and input the values. So we have 1, -3. Once I input the matrix, I'm going to hit enter. And step 4 is my solution. So therefore, matrix X equals 11 and -18.
And that's the answer. That's the answer.
That's step 4. So again, we made sure that it had a solution by finding the determinant. After we made sure there was a solution, then we therefore found the inverse of the 2 by 2. Remember, you only can find the inverse of a square matrix. So we found the inverse of the 2 by 2. Step 3, we multiplied the inverse times the value, the matrix, the 2 by 1 matrix on the right side, and then found the solution of our missing matrix. Notice how I did the 2 by 2 times the 2 by 1. If you input that incorrectly, it will not work because it'll be a 2 by 1 times a 2 by 2, and that will fail the smile test. So you will not get an answer. Questions, comments, concerns? Already RC, yes, always RC. Row column, row column. All right, here's our second example. So our second example, we have 3, -9, -2, 6 times matrix X equals 2, 5. Step 1 is always to find the determinant to know if you even need to go any further. So the determinant here, 3, -9, -2, 6 equals, if I cross multiply, 3 times 6 minus -2 times -9, that equals 18 minus 18. And what does that equal? 0. So what does that mean? There isn't an inverse, so therefore there is no solution for this problem. That becomes a positive 18, but there's a minus right there. Okay. Questions about a no solution example. Now, if you try to go through the steps without checking the determinant, it'll end up tell you have an error in your calculator. And this would be the reason why you would have the error. All right.
Did you have an error for like doing something else?
For multiplying the wrong order. All right, here's yours to try, example 3. So from start to finish, I would like for you to try independently. During this time, it doesn't mean take out your cell phone and check your notifications or respond to a text or change the song. It actually means try. Pause the Netflix, pause the whatever you're watching, pause everything and try. All right, let's see how we did. So step 1 is to make sure that there's even a solution possible. So the determinant 4, 3, 2, 2. That equals, we have 4 times 2 minus 3 times 2, which gives me 8 minus 6, which equals 2. So that means their solution exists, right? So then I proceed. Step 2 is to find the inverse of 4, 3, 2, 2. So in the calculator, I'm finding the inverse. If you feel like you want to, remember we also learned how to find the inverse algebraically. If that's where your heart tells you to go, then go there. So I put in to find the inverse, and I end up with my inverse equaling 1, -3/2, -1, and 2. Step 3 is to multiply the inverse times the constants over here. So I have -5 and 2. So I'm going to arrow up, grab my inverse, and multiply it by my 2 by 1, -5, +2, and I hit enter, and I get that my solution is, x equals -8, 9. And that's how it's done. How did we do? Yes. Right here. I didn't multiply my inverse by 2. I didn't multiply anything by 2. I multiplied my inverse times my solution. All right. We're going to move to the other side. So on page 58, it said that you're going to write a systems to matrices definition. And so basically it's our example. You can write it in words, but it's kind of better to look at the example. So systems of equations, we've learned how to solve them various ways using tables, graphs, elimination, substitution. But the last way is matrix equations. So using matrix equations, and reduce and RREF, we've also learned that. The last way of solving a system is using matrix equation. So to turn a system into a matrix equation, you make a 2 by 2 of the coefficients. Remember, coefficients are the numbers with the variables. So notice how they made a coefficient matrix. Your 2 by 1 matrix is what variables do you have? So we have X and Y. And then the last 2 by 1 are your constants. So 1 and 13. So this is how a system becomes a matrix equation. Coefficients make one matrix, variable makes another matrix, and your constants makes your last matrix. I'll give you a moment to write this down. All right, so here's our first example. So we have the system 4x plus 7y equals 6 and negative 5x plus 3y equals 1. And we're going to turn it into a matrix equation and solve for x and y. So the first thing we do is create our matrix equation. Remember, your coefficients become your first matrix. So our coefficients are 4, 7, negative 5, and 3. Your variables become your second matrix. Our variables are x and y. And your constants become your last matrix, which is 6 and 1. Does this look any different than what we just did on page 57? No, it's not. So you go through the same steps that we just did on page 57 to solve for x and y. So step 1 is to check the determinant. So we check our determinant of our first matrix. So I'm going to check this determinant and we cross multiply and divide. So we have 4 times 3 minus 7 times negative 5. And what do we get? 12 plus 35. So what does that tell us? That there is a solution, right? So we have 47. That's just letting us know that there's a solution. And so then we proceed. So we're going to go to our calculator. Let's go to our handy dandy calculator. And at this point, we should be able to just go straight through the calculator, right? So we're going to find the inverse of our 2 by 2. Clicking on that. We're going to input the values 4, 7, negative 5, and 3. And we're looking for the inverse. Remember, it's your caret. Get your little tiny box and put in negative 1 to find the inverse. And we get a lovely fraction. And remember, fractions are our friends. We don't change our friends. We let them be great. Okay, so we're going to arrow up, grab our fractions, and then we arrowed up, highlight, and now we're going to multiply by our constants. So we have our constants, and we have 6, 1, enter. And that is our solution. Fractions are our friends. They are real answers. They count. They matter. So we have x, y equals, and we have 11/47 and 34/47.
What, 47? 11:47?
Did you do it on your calculator, Gerardo? Okay. Okay, how do we feel? Okay. It all comes together. So this is another way, the last and final way to solve a system. We're going to do a 3 by 3. Are the steps going to change? No, it's not. So we're going to do a 3 by 3 because are there not three system variables? Yes, there are 3 variable systems. I skipped a word in there. Okay, so our last example is our 3 variable system. Same thing, exactly the same, except instead of dealing with a 2 by 2, we have a 3 by 3. Nothing else changes but the size of our matrix. So our coefficients are 4, -2, 3, 1, 3, -4, 3, 1, and 2. Agree? What are our variables? X, Y, Z. That's what we're trying to find. What are X, Y, and our constants are 1, -7, 5. I'm going to do this solely in the calculator. Okay. So in the calculator, if you want to check that it has a determinant, you can. So that's the DET parenthesis. And we're going to put our matrix in there. It's a 3 by 3. So I make sure it says 3 by 3. Hit OK. I'm going to put in 4, -2, 3, 1, 3, -4, 3, 1, 2. So we have it in, and there is a determinant. So what does that mean? There is a solution. Okay. DET. So we did DET, like type DET, parenthesis, and then we put our matrix. Okay. So there's solution. I'm lazy and I don't want to retype my matrix. So I'm going to arrow up to where I typed it. And I'm just going to delete what I don't need, which is I don't need DET, right? So if I delete that, I'm good. And now I can find my inverse. What didn't work? The DET goes in the front of it, sweetie.
You can leave the parentheses in?
No, I deleted it. So again, I didn't want to have to retype my matrix because you didn't put it. Hold on, Alexis. Look how it's written up there. It's DET parenthesis. All right, so you have to wait. I'm going to delete the parentheses, delete the DET, so that I have the matrix, and now I can find its inverse. So instead of having to constantly write it over and over, I can use what I have. Here's my inverse. It's a bit intense. At least you didn't do it by hand, right? Okay. After I have my inverse, then what do? I multiply. I multiply by my constants. I need a 3 by 1 in order to put in 1, -7, and 5. So I'm going to click here, click matrix, and I need a 3 by 1. Hit OK, and I'm going to put in my values 1, -7, and 5. It looks intense, right? But it's not in the end. And you can modify it. And then you hit enter. And what is our solution? -1, 2, 3. So we have X, Y, Z equals -1, 2, 3. Which means that the solution of the system is -1, 2, and 3. And that is the end of our matrix unit. The end. So the plan is, I decided not to give a Monday test. So on Monday, you're going to be doing your, I'll change the date. And the thing, you're going to be doing your 3-6, 3-7 classwork and working on your unit 3 test review if you have not completed it. The test will be on Tuesday. No ifs, ands, or buts.